Hi, in this video we're going to talk about the critical Z values and how they're related to the confidence levels, and those are the numbers that are part of the formula for the confidence interval. So we're going to do this with 4 different confidence levels, and it's not only good practice, but it also will allow us to see a pattern with what's going on between the confidence level and the Z star. Okay, so let's look at 99% confidence first. You know from the empirical rule that if we go 1 standard deviation away from the mean, that is 68% of the probability. If we go 2 standard deviations out, that's 95%, and 3 standard deviations out is 99.7%. So we are just inside. I'll try to emphasize it a little bit. We're just inside of this 99.7. Right? We'll figure out exactly where this falls when we find our Z score. So we're trying to find essentially how many standard deviations out do we need to go to capture 99% of the values. Okay, so since we're using a Z, this is a Z value, that means we're using a mean of 0 and a standard deviation of 1. So this will go 0, 1, 2, 3. And -1, -2, -3. So we would expect it to be between -2 and -3, or between +2 and +3, right? We use the Z-score so this it's independent of the mean and standard deviation. We can always start it back at 0. Okay, so we're trying to figure out what this value is. In other words, how many standard deviations away is it? So this is our middle 99%. If I shade in between those 2 places. And now we want to find this Z, essentially as a Z score. We want to find these Z scores or Z values. So remember how we did that? We've done something similar where we found the values that captured the middle 50% or the middle 60% or the middle 25%. Remember? So we had to, if there's 99% inside, we have to figure out how much is left outside. So 1 minus 0.99. If you said 1%, you're right. 99% inside, 1% outside. Then we have to cut it in half because we have 2 sides and it's symmetric. So 0.01 divided by 2 is 0.005. Just double check that. Yep, I already did it. 0.01, I'm psychic. 0.1 divided by 2 is 0.005. That means this area over here is 0.005, and this area over here is 0.005. Okay, now, do you remember how we found these values in GeoGebra? I bet you do. So I'm going to pull up GeoGebra here. And we have our normal 0, 1. And we are trying to find the area, if we want to do this one first, try to find the area to the left, the value, where the area to the left is 0.005. Enter. Okay, so this is -2.5758. We want our calculations to be very accurate, so we're going to use all of these decimal places. Unless something says otherwise in my open math, we'll use all of these places. Okay, so how we found this was probability that Z is less than or equal to what equals 0.005. Oops, sorry, you can't see that. Let me close up GeoGebra for a second. Probability that Z is less than or equal to what value equals 0.005. And that was -2.5758. Okay, now we can do the same thing for the upper value, right? Do you have a guess as to what it's going to be? this up again. And now we're going to go to the right and put in 0.005. And it is, voila, 2.5758. Does that make sense? Because it's symmetric, right? So it has to be the same on both sides. One is negative, meaning you're below the mean, and the other one is positive, meaning you're above the mean. So what that tells us is 99% of the area is within 2.5758 standard deviations of the mean. Okay, so we're going to be using that number because we want to make our margin of error go out that many standard deviations if it's 99% confidence. Okay, let's do the next one, or if you want to try it yourself, just pause it and do them all yourself. 95% confidence. Well, that number might sound familiar to you because it's 68.95. I believe remember that empirical rule is approximate. So I believe it's just inside, because it's approximate, 0.95. We'll find out for sure. I think it's just inside the 2 standard deviations. So again, we have 0, 1, 2, 3 standard deviations, -1, -2, -3 standard deviations. Okay, can you find these numbers right here? Different color. So if we do 1 minus 0.95, that's 0.05. And 0.05 divided by 2. Oops, you can't see that. 0.05 divided by 2 is 0.025. 0.025. 2.5% makes sense. So 0.025, 0.025, and go to GeoGebra. Punch it in. I'm going to do less than. Doesn't matter which one you do because they're going to be the same except for the sign. And we want less than or equal to 0.025. -1.96. I had a feeling, I've done this a few times, so you can imagine, that it was just inside that 95, or just inside 2 standard deviations, but very close to 2 standard deviations. So this one is going to be 1.96. So the way we found that is, move that cursor, the probability that z is less than or equal to what equals 0.025, and that's what we got, 1.96. Oh, there's one thing I want to fix here. When we talk about the z-score, we actually don't put the negative sign. I wrote it because I found the negative one first. Get rid of that. We just give the positive value, 1.96. And the reason is, in the formula, it's already built in, the plus or minus part. So we just need the value. Okay, so I shouldn't have put that negative sign there. Okay, you want to keep going, try it on your own, or pause it and then just blow through this to check your answers. I'm going to keep going, the 90% confidence interval. So 68.95, so it's somewhere in here, right? Somewhere in here. It's 90. So you can also start to see what's happening with the pattern. 0, 1, 2, 3, -1, -2, -3. And we need these values right here. So 1 minus 0.90, complement of 90% is 10%. So that's going to be 5%. Divide that in half. We're going to get 5% on each side. Okay, 5%. So then should be between 1 and 2, right? Probability that z is less than or equal to what? Equals 0.05. So let me put this in GeoGebra. Let's get that a little bit. In that spot we will put 0.05. And we get, for the left side, we get negative 1.6449. So that means for the right side, that will be positive 1.6449. And that is our value here, 1.6449. Okay, what's happening? We're getting, we're taking a wider area, right? And we're getting narrower as the confidence goes down. And then the z value is also getting smaller. Makes sense because we're going fewer standard deviations from the mean. Okay, one more. 80%. So 68. It's got to be inside the 90, right? But more than 68. So somewhere in here, maybe just outside 2 standard deviations. 0.80. So we take the complement. 1 minus 0.80 is 0.20. So 20% on the outside, and half of that is 10. So we have 10% and 10%. And I could label 0, 1, 2, 3, negative 1, negative 2, negative 3. Let's find our z-score, z-star. Probability that z is less than or equal to what? Equals 0.10, 10%. So here's GeoGebra. I'll just change that to 0.10. Negative 1.2816. So this one will be positive 1.2816. Let me scoot that up. It's not quite as in focus at the bottom of the page there. Okay, so here's our z-star for 80% confidence. 1.2816. Okay, let me just double check where I'm going here. Okay. Okay, great. So just to summarize this page, let me zoom out. You can see how the higher the confidence, the wider we need to go, the more standard deviations we need to go out. And so that's going to be part of our formula. Okay, so this video was all about the z-star, critical z value, and we'll keep going on the next one. I'll see you there.